All right, so this is for Science 24, and today's lesson is on 1.4, Chemistry at Work. So just a few examples here of how chemistry is used at the workplace. So if you've ever worked at a swimming pool, or if you've ever gone to a swimming pool or a golf course, a lot of knowledge of chemistry is required in lots of jobs. So for example, at a swimming pool, there's chlorine usually in the swimming pools, and that chlorine level needs to be tested several times a day because additional chlorine may be needed. And again, that chlorine keeps the water safe for people to keep swimming in. Other chemicals may also be needed to be added to the water. Next is a golf course. The fairways and the greens need to be sprayed for weeds several times a year. That's why the grass always looks so nice at the golf courses. It's because they spray for weeds several times a day, several times a year. They also use fertilizers to the grass. It's applied regularly. And also, the greens need to be sprayed before winter with a special chemical which prevents molds from growing under the snow as spring approaches. Next, we're looking at welding. So hundreds of years ago, chefs, blacksmiths, and welders were using chemistry. So we already talked about chefs last class with baking and cooking. Here we have welders. So welders work with metals, and they knew that pieces of steel had to be heated to very high temperatures to melt them so that they can be welded together. So there's a chemical change occurring here involving acetylene, it's a gas, and oxygen. So acetylene gas and oxygen produces enough heat to melt the steel. And back in those early 1900s, blacksmiths were working as welders as well as mechanics and figuring out how to work with metals and weld metals together. So here in this diagram, we see an acetylene torch, which is using a chemical reaction. It's going to produce carbon dioxide, water, and then enough energy to melt the steel. So again, that's an acetylene torch. So today, chemistry is used in basically every workplace. So for example, at an automotive repair shop, you've got paints, fillers, cleaners. Those are all involving chemical reactions. There's special car paint that protects metal, cars from rusting. There's waxes and polishes that protect the paint. And as well, if some of the paint gets faded by the sun, there's special waxes that may remove tiny amounts of the paint and then restore the shiny appearance. In the hair salon, again, everything but the scissors involves a chemical change. The color solutions, curling solutions, perms, shampoos, conditioners, those are all involving chemicals. In an office, there's hazardous chemicals present in inks and toner cartridges. There's correction fluid, fire retardants in paper, upholstery, and carpets. And then construction sites, there's hazardous chemicals in the explosives, any wood preservatives, paints, solvents for cleaning up. And remember that solvents that are used to clean grease or wash windows include a base called ammonia. And that ammonia, again, is a base. It's a very basic solution, and it dissolves grease. It'll dissolve any grease, wax, and window dirt. In cosmetics, a lot of chemistry is involved in cosmetics as well. So again, we talked about shampoo. Shampoo sometimes will also add texture to the hair. And the reason it does that, for example, if you have volumizing shampoo, it's because you're actually putting plastic in your hair. So those shampoos usually have a plastic resin within the shampoo, and it basically covers the hair with that plastic resin, and it makes the hair appear thicker and it improves its texture. If you've ever used soap in the hair, so before 1938, that's what people were using. They were using soap in their hair, and that was leaving hair pretty dull and rough looking. So the reason why that happens is because soap is a base, and that base, it breaks down proteins, and our hair is made of proteins. So that's why the hair was left looking dull and rough. But soap will also react with the calcium in the water, and it'll leave a scum layer on your hair. So that layer also made the hair look dull and also made it difficult to comb through. So back in the olden days when there wasn't shampoo, hairstylists used to use an acid rinse that was made from vinegar or lemon juice, and then that was used to dissolve the scum to make the hair look nice and shiny again. All right, so shampoo, then it's a synthetic detergent. So synthetic again, meaning human-made, and it helps wash the oil and the dirt from the hair, but also keeping the hair looking healthy and shiny. And then we have dish detergents that wash away grease and dirt from dishes, also synthetic. Here we're just looking at the pH scale. So very important here is this pH scale. In the middle here we have the number 7. That number 7 represents substances that are neutral. So they're not an acid or a base. If you move to the left side of this scale, you have the numbers 0 to 6, and those are all acids. All right, so moving left, we get acids. For example, stomach acid, it's got a pH of 2. Acid rain ranges from a pH of 3 to 5. And then at 7 is usually pure water, or like distilled water, would be at a neutral pH of 7. As you move to the right hand side of this scale, going from 8 to 14, those are bases. So for example, blood has a pH between 7 and 8. The seawater is just a little bit more than pH of 8. Detergents here are between 10 and 11. And drain cleaner, which we talked about last class, has a pH of 14. All right, so acids on the left, neutral is at 7, and then bases are on the right. All right, so next looking at cosmetics. Cosmetics, which include like face creams, makeup, lipsticks, blush, foundation, all that stuff. It's been around for thousands of years. Some are harmless, others are not. Many chemicals are tested on animals before being used on people, but many groups oppose the use of animals in testing cosmetics. So nowadays you'll see a lot of manufacturers, they'll advertise that their products have not been tested on animals. And basically researchers used to study how much the animals are affected before allowing that material to be used on humans. Next are these WHMIS symbols for workplace. So last class we talked about the HHPS symbols. Those were for household substances. These are WHMIS symbols. These are for the workplace. So WHMIS stands for Workplace Hazardous Materials Information System. So if a dangerous substance is found in any workplace, that includes schools, offices, restaurants, repair shops, you will find a WHMIS label on the container. And it's very important that you do read the label before ever handling a substance that you've never used before. So these are the symbols on the right-hand side. Compressed gas, flammable, oxidizing material, corrosive, poisonous, toxic, biohazardous, and reactive. So make sure that you do know those symbols and what they represent. And lastly, there is also a sheet called the MSDS sheet. So that stands for Material Safety Data Sheet. And if you're working with hazardous materials, you should always go read the MSDS as well. It provides a more detailed information that is not, that doesn't fit on the product label. So that's the MSDS sheet. All right, so for homework today is the 1.4 questions, which are numbers 1 to 2. And then because we finished chapter 1, there are the chapter 1 review questions, numbers 1 to 20 to work on for today.